So for doing this, this is page 40, number 1, which is a over a plus 1 is greater than or equal to 3.
How about
3
over
3, thank you. Common denominator of a plus 1, a plus 1. This cancels, that cancels. I'm left with a 3 is greater than or equal to 3a plus 3. I multiplied right this time. I learned. Which means if I bring this over, I'm going to have 0 is greater than or equal to 3a. So 0 is greater than or equal to a, or a is less than or equal to 0. Okay? Problem number 2. I don't think I have enough room to do problem number 2, but we'll try. 1 over x is greater than or equal to 4x. Common denominator is x, so that means I need to multiply this by x, this one by x, right? That x cancels that x. I got 1 is greater than or equal to 4x squared. Dividing both sides by 4, I have 1/4 is greater than or equal to x squared. Taking the square root of both sides, because this is x squared, and this happens to still be positive, I can have x, square root of 1 is 1, square root of 4 is 2, and because I took the square root, it's plus or minus. Or x is less than or equal to plus or minus negative.
I didn't have the plus or minus thing, would that be wrong?
Actually, it would be. Yes, you need the plus or minus. Okay?
Alright.
So we're alright with that then? So we got problem number 3, which is 1 over 2p plus 4 over 5p is greater than 2/3. For the numbers, it'd be 10, about 30, so I bet it's 30p. 30p, 30p. Well, 2p will go into 30p 15 times. 15 times 1 is 15. 5p will go into 30p 6 times, so I'd have 24. And 3 will go into 30 10p times, which means that I'd have 20p. So 15 plus 24 is about 39. It's greater than or equal to 20p. So p would be 39/20ths, and I don't think I can reduce. Or p is less than or equal to 39/20ths.
Not equal to those, just
Okay. Sorry.
fix them on top, but thank you.
Thank you. Then I screwed that up yet. That way. Alright? I know, I'm going through them quick, but I want to get through them all. Number 4. 3 over 2x minus 2 over x is greater than 1/4. My guess is my common denominator would be 4x. I will post this video and you can look at it at any time, so you can slow it down if you want to. 2x goes into 4x twice, so I'd have 6. X goes into the 4x, so I'd have a negative 4 times 2 is a negative 8. 4 goes into the 4, so I'd have greater than x. So what's 6 minus 8? Negative 2 is greater than x, or x is less than negative 2. You're on fire? Want me to get a bucket of water? Okay. In other words, it's not going along with liar, liar, pants on fire. Is that what you're trying to say?
No.
Okay. X minus 1 and x minus 1 and x minus 1 and x. Common denominator. This one cancels this, so I'd have 4x. This cancels this, so I'd multiply and have 5x minus 5. Nothing to cancel here, so I'd have 2x times x minus 1, and I still need to multiply it out. So 4x plus 5x is 9x minus 5 is less than 2x squared minus 2x. Zero is less than 2x squared minus 11x plus 5. I moved it all to the right-hand side so that I could leave this x squared positive. That's why I did that. Can I factor 2 times 5 is 10? What two factors of positive 10 equal a negative 11? How about a negative 10 and a negative 1? So, working on that factoring down here, I would have 2x squared minus 10x minus 1x plus 5. So, taking out the 2x, I'd have x minus 5. Taking out a negative 1, I'd have x minus 5. Common factor of x minus 5 will leave me with 2x minus 1. So that means up here I have 0 is less than x minus 5, 2x minus 1. So 0 is less than x minus 5, or 0 is less than 2x minus 1. Now why did I use an or this time? Because usually we have this stuff over on the left hand side. Well, if I flip this, wouldn't this be a greater than then? Instead of a less than?
Yeah.
Well, with greater thans we use ors, don't we? So right now I have 5 is less than x, or 1 is less than 2x, x 1/2, or x is greater than 5, or x is greater than 1/2. Okay? And the last one.
Okay.
Huh?
We already did it.
Then you have to put it on the video.
Oh, okay.
Just so that I'm sure the first hour class would like to have it, in case they ever watch the videos. X plus 1, x minus 1. So that means x plus 1, x minus 1, x plus 1, x minus 1, x plus 1, x minus 1. Right? All of this cancels all that, so I got a 3. All of this multiplies together, so I have this. And this cancels this, which will give me 2 times x plus 1. So I'd have 3 plus x squared minus x plus x minus 1 is greater than 2x plus 2. Did I do it right that time?
Yes.
Yes. So I'd have x squared plus 2 is greater than 2x plus 2. Bringing all of this over to here, I'd have x squared minus 2x. 2 minus 2 is 0. I'd be left with a 0 on the right-hand side. Factoring it, I'd have x parentheses x minus 2 is greater than 0. So x is greater than 0, or x minus 2 is greater than 0. That one's done. That one's that. And remember we said you need to check. Well, I have something greater than 0, something greater than 2. I'm sure all these numbers are going to work. But if I put in a 1, and I go back up into here, 1 squared is 1 minus 1 is 0. I can't have a denominator of 0, right? If I put it in here, I'd have another denominator of 0. Can't have that, so I'd stick with the x is greater than 2.